Hey everybody, welcome back to Human Factors in Aviation, and this week's topic is communication factors. Quick overview today. We're going to talk about grammar, punctuation, a little bit of that, but we're going to talk about communication, elements of good communication, things that keep us communicating well, and we're going to talk a little bit about fatigue. One of the first things that happen when you get tired is your inability to communicate effectively. And somebody who's built their entire job around communicating with pilots is air traffic control. And so here's one way to put it: let's eat grandma. It doesn't mean the same thing as let's eat grandma. Okay. And in case you don't know the difference between the two, this is correct at the dinner table. Let's eat, comma, Timmy. Let's eat Timmy is correct on a raft in the ocean. Okay. So punctuation saves lives. Okay. It's not just what you say and the letters you use to say it, it's how you say it and sometimes how you present it. So we're going to try to talk about some of that today. For this one is chapter 4 of the Aviation Instructor's Handbook that we use for reference. Effective Communication is what is titled. This book and this chapter is geared towards teaching a flight instructor how to effectively communicate with their student. So we as CFIs can be a better listener, and so we can communicate better, and so we don't just talk at the student the whole time. So the idea behind this chapter is to give you some of the tools you need to become a better communicator, not a better speaker or a talker, but a communicator. Of course, this is actually a pretty tough subject to talk in a 1A video here because I'm going to talk about getting feedback from the students, but in a one-way video such as this, I don't really get that feedback from you as the student. So what I do then is I have exams and discussion boards to give you an opportunity to provide feedback to me. That's how this communication is going to have to work in this week's module. So, really quick, what do we mean by effective communication? It is based on the similarity of the idea transmitted by the source and received by the sender. So, we have a source, the person who sends the communication, the message itself, that's the symbol, and the receiver. So, right now, I'm sending this video to you. The message would be the video, and you are the receiver because you are watching it. Now, ideally, once again, communication is a two-way process. I get some feedback from you, and that's going to be in this class, and the grades you get on this week's quiz or the grades you get on this week's discussion board. In class, we would do a little bit more back and forth. So, some of the justification behind all this: about 70% of the first 28,000 aviation safety reporting system reports were related to communication problems. I'll talk about ASRS reports later on in this class, what they are is, and what they are. So these are safety reports that came from pilots to NASA basically, and they compile the information and then gives it to the FAA. So 70%, all right, almost 3 out of 4 of these reports that were being filed were related to communication problems. And the vast majority of those communication problems included either transmission problems, like the message came through garbled or unclear. Like think watching movies about old radio calls and about how it's all staticky and you can't really hear them. Listen to AM radio and there's a bird flying between you and the antenna or something like that. So we try to fix that by having more clear communication, by having better radios, better microphones, and better speakers and stuff like that. Message problems, as in an unclear message, as in it came through clearly, but what was being said wasn't being understood. It was in the wrong language, it was using the wrong terminology, the wrong vernacular, the wrong tempo, or the wrong format, things like that. Or understanding problems. That would be the transmission was good, the message was good, but it was a little vague on the intent. Uh, like calling up on the radio and saying, "Am I cleared?" No matter how clear the message was, no matter how good the transmission was, we don't know who that pilot was talking to, who that pilot is, or what that pilot is asking that they were cleared for. So don't be too vague on the radios because it's only going to get in the way of effective communication. The three basic elements of communicating are the source, the symbol, and the receiver. We've already touched on this, but now you get to see it. So we're reinforcing the auditory learning with the visual learning. Okay, so the source would be whoever sends the message. It's the sender, the speaker, the transmitter, the instructor talking to the student, and so forth. The messenger is the symbols. That's the signs, the words, the messages, and the images we're trying to convey. and then the listener is, I'm sorry, the receiver is the listener or the reader, the learner, anything like that. So once again, in our situation that we're dealing with right now, I'm the sender and I'm sending a video from my computer to you. The symbol is the video. I am the source and you are the receiver. And a lot of stuff can go wrong there, right? I can send an unclear video. The audio could be bad. The video could be bad. You could be downloading on a very low resolution. You can't really see the detail I'm showing. All those problems happen both with video and with audio. And most of the time in aviation, we're only dealing with audio. We say it's a two-way streak, okay? So it's not just, well, in person, it doesn't go like this video is going, right? In person, let's say your CFI would say, hey, today we're going to do stalls. That's, you sent the message, you encoded it and put it into words. Okay, you send the message to the receiver, they decode it, and they're thinking, stalls? I need some kind of a feedback from you. It could be a look of confusion, it could be a nodding, it could be a deer in the headlights look, or it could be a question like, will it restart if it stalls? I'm like, no, no, no. That's not what we're talking to. It's an aerodynamic principle. So most of you are in 101 or you've taken it before and you understand the principle of an aerodynamic stall. But this is the basic example of, we're going to do stalls today. Oh no, what happened to the engine? No, no, I'm not talking about the engine. But that clears up some unclear communication and makes our communication more effective with that feedback. I get feedback from you in quiz scores, discussion boards, and direct email communication from a lot of you. So that's the feedback that I get, and I do appreciate it. So when we're flying an airplane, we're in an airplane, we're by ourselves, we're thousands of feet. Who are we talking to? Well, we're talking back and forth with other people in the cockpit with us. So we might be talking to our flight instructor, our flight attendant, our first officer, our passengers. We're also talking to people in other airplanes. We might be talking from the cockpit to the cabin crew, or from the front of the airplane to the back of the airplane where the passengers are. We might be talking to other airplanes. We might be talking to air traffic control. Air traffic control might be talking to other air traffic control towers, and then they hand us off, and then we talk to another flight air traffic control tower. There's a lot, and 99.9% of all the communication we're talking about right now comes verbally, over the radio, using words, not using symbols, light guns, text messages. Those are all used in emergencies, but for the most part, everything you say and do is going to be over the air on the radio. Now, in a perfect world, everybody would know what everybody else is doing, and that's becoming easier with what we call ADS-B, or Automatic Dependent Surveillance Broadcast, which is basically your airplane transmitting its position to any other airplane and air traffic control, so then they can retransmit the position to all the other airplanes and all other air traffic control towers, enough to where I can log in on the internet at home and I can bring up a chart of where everybody is. So for instance, that's what this website is. It's showing us all the ADS-B data from airplanes flying throughout the world. It's a European-based company. That's why it always defaults over there, I believe. And we're talking about here just in Southern California, we can see how many airplanes right now are currently being tracked and flying around. It's not even all of them. As I zoom in, it populates more and more and more until I zoom in all the way. And I will actually say that this isn't even all the airplanes that are currently flying right now as I record this video. There are more that aren't even showing up on here. Most of them in these busy metropolitan areas like Southern California do show up because we're required to have that equipment here for that increased situational awareness. So without communicating, I can actually, using my iPad or some aircraft that are equipped, I can look and see what that airplane is. I can see what they're doing and where they're headed. And and as the more practice you get, they clearly just did an instrument approach. They're getting vectored in towards the ILS approach to Montgomery Airport. They started up in Sacramento a few hours ago. Where's Southwest 1590 going to? They're headed off towards Sacramento. Where'd American Airlines 1939 just come in from? From Dallas, Fort Worth. What are these helicopters doing? Where are they going? And some are private owners, some are military, some of them are police that'll show up on here. Very fewer military aircraft show up, but a lot of EMS and police departments will show up on here. To again, the whole idea is to help build that situational awareness. So these different types of communication, let's break it down a little bit more. Let's talk about internal communications. By that I mean inside the cockpit or between the cockpit or the immediate people right behind it. If let's go non-aviation for a second. This would be like people in a team in a business environment. So on one floor or one group of people who are working together on a project. That's all internal communications. So we don't mean you talking to yourself. I mean you talking to other people inside your bubble besides you and the voices that are in your head. Once we leave the aircraft, once we leave your small team, or once you leave potentially the cockpit and talk to other cockpits, then you're external communicating. You're communicating externally. And same concept, but you start to introduce more confusing elements because you might be talking to somebody else who's clearly in a different location, and they might want to say things differently or do things differently. They might have different policies, and then they can't see you. That's the biggest difference between internal. You can usually see the person you're talking to, and external you cannot. So in aviation, we do most of our communication is still done through voice communication. In general aviation, we use VHF radio frequency bands. It's very high frequency, is what VHF stands for, and it has to do with the wavelength, the megahertz of the frequency you're tuning in. So for anybody who does radio stuff, this is about between 108 to 117 to 118. That's for our navigation frequencies, and that's megahertz. And from 118 megahertz up to 136 megahertz is our communication frequencies. And if you're flying in a general aviation aircraft, that's pretty much all your radio will tune in. If you're flying a military aircraft, they have ultra high frequency radio bands. It's a totally different set. It's higher megahertz. They're a higher frequency. Or on the other hand, if you have an old aircraft or maybe a ship or a land-based radio, might be a high-frequency radio. It's much lower frequencies, lower megahertz. It's a longer wavelength, and they all have their own different properties. So the biggest thing that we're really going to focus on here is VHF communication. That's what you primarily use to communicate with air traffic control. Now, let's say if you have an emergency and your radio stops working or your electrical system fails, then you can call them on the phone if you have, the equipped headset that you can use to talk on the phone, or good earbuds, or you could potentially text if you know who to text. Those are all emergency items only. And then also another thing we do in an emergency, let's say if you can't talk to the tower, you could squawk a transponder code 7600 on the radar screen tells them that aircraft is Nordo or they have no radio. And then they would communicate to you with light gun signals. They have like a big bright light in the tower, in the ATC tower. They can point at you and either have it white, green, or red, or a combination thereof. And that's a way of them visually communicating with you because you cannot communicate verbally. And then you would respond back with things like you rock your wings or you flash your navigation lights at them. That's kind of a way for you to visually respond to them as well. Again, these are only for emergencies. For the most part, it's only going to be for an emergency, with very few other exceptions. Let's say if you go somewhere you're not supposed to during a game or presidential visit, you might get intercepted and escorted by your local law enforcement or military aircraft. So it's not uncommon for pilots to do a flight they did the day before, but today they're minding their own business, and a couple F-18s pull up next to them. And they can't just yell "pull over," right? Because there's a lot of noise going on in altitude. So they have their own set of intercept procedures. If they get in front of you and lower their landing gear, they expect you to lower your landing gear and land with them. If they break off really fast in a maneuver you can't follow, they don't want you to follow them. And then if they fall behind you and beep starts going off inside your cockpit, that means they've locked on a missile to you. I'm really kidding because you probably don't have the ability to know that they've locked on from your general aviation aircraft, so you'll never know until things get really bright and then really dark. Let's talk about what's really going to happen. That's a worst case scenario, but so again, 99% of your time is spent verbally communicating with them. Now, once you start flying commercial aircraft, large transport category jet airliner aircraft, their routing is not going to be handled verbally over the radio. They'd be there all day talking on the radio just to get an instrument clearance somewhere. So one of the things they do is they get a pre-departure clearance. So let's say if you're going to fly a commercial airline, Delta, American, Southwest, um, or any of the others. I'm not I'm leaving out. Okay, don't not to upset anybody's favorite airline. What happens is their dispatcher files their route for them, and then they get a clearance that they send to the cockpit of the aircraft. So in the cockpit of the aircraft, they would kind of get like a text message they receive. Would you like to import this flight plan? Yes, I would. And you click yes, and it loads the whole flight plan into the computer for you. Now, it eliminates all the human error of radio communication and data input and all that other stuff. So that way, the pilots, all they have to do is verify that the flight plan is correct as opposed to putting it in themselves. And then your aircraft actually communicates with the owner of the airline as well. That's the ACARS, the Aircraft Communications Addressing and Reporting System. And most aircraft have either an ACARS or a version of it. That's the aircraft sending its position and whether and if anything's going good or bad back to home base, if you will. So let's say if it's Southwest Airlines flight, then the ACARS system on the airplane would just at normal intervals would keep sending its position and its status really back to the mothership, if you will, back in Dallas Love Field. And so they would then, if something goes wrong with the airplane, if there's a pressure problem or a temperature problem or an engine problem, there's a good chance that the maintenance hub knows before the pilots do, or knows before the pilots told them at least. So let's say if there's an emergency in the air and the pilots are busy handling it, somebody else is going to get notified by the airplane, and they're already going to be working on the solution to help the pilots out too. And that's where some of these aircraft, especially if we're talking about the over ocean aircraft, get some of their positions from. So we have our ADS-B data, but then we also have, if I can zoom over far enough, but then we also have the ACARS reporting the position for these aircraft too. So especially some of these way out over the middle of the ocean, like they're not being necessarily reported by ADS-B and transponders, but it's the ACARS system is what's reporting the position of this aircraft right now, and it's being shown up on our screen here. Okay, so how do we effectively communicate then? Well, let's talk about what happens if we don't. Okay, you lose situation awareness, crew resource management, which is the an earlier iteration of threat and error management, starts to break down. You don't communicate well enough. You make bad decisions that increase risks. So bad communication at its simplest level could cause you to drop somebody on their head, but it could lead to a whole lot worse things too. And to clear up vague communication, is it like, for instance, do you lift on three, or is it 1, 2, 3 lift? Is it 1, 2 lift, or 1, 2, 3 lift? Right. So that's what they need to figure out here in this operating room. So what gets in the way? Well, the single greatest barrier to communication is the lack of common experience. Now, this is in bold letters because I want you to know this for the exam that comes up later on. So once again, thanks for watching. And for those who didn't watch this video, don't understand why that's the right answer and why they got it wrong. So the biggest single greatest barrier to communication is the lack of common experience. Okay, and especially in flight training. You have a commercial pilot with hundreds or thousands of hours and a student pilot with no hours. There's not a lot you have in common. You don't you probably don't even hang out at the same places or drink the same beers. Even if you do, that's kind of where it ends, okay? So we have this skill that we have that you don't, and we're trying to teach that to you, but we can't. There's so much new stuff to talk about. I mean, our private pilot ground school is a great example. We have to start with the new language of aviation and how to read charts and what words mean differently now than what they used to mean. And then we have to build on with, and that's how you apply it to new knowledge. And then we go apply it in the simulator, and then you go apply it in the airplane itself. And it has to kind of go in that order. Otherwise, it's just too much. It doesn't mean you can't go take a flying lesson today, not having taken any ground classes or any simulator classes, but you have less in common if you do that, and it makes it harder to communicate. Another one is the confusion between the symbol and the symbolized object. In other words, what you said versus what you mean, or what they think you said versus what you meant, is probably a better way to say it. So the symbol is the message that's being sent. So if I send this to you and the video doesn't match the audio, it's super confusing. So I need to make sure that the right video at the right time goes through with it. Even if the audio is off by 5 seconds, then my pictures wouldn't match the images, right? The audio that I'm talking about it. So for instance, some examples. Stall, we already talked about that. Tractor, this is a tractor configuration airplane. Okay, it doesn't mean there's a John Deere hooked up to it pulling me through the sky. It means the engine is in front of me pulling the airplane through the sky. That's what tractor configuration means. Or prop. So this is an airplane propeller, or prop for short. This is a controllable pitch, nice, beautifully curved one on a Cessna 177 RG here. But if you're a boat person, this is a prop to you, or a screw. Okay, it's still a propeller that propels the thing through the air. This would be in a pusher configuration, by the way, because it's behind the ship, not a tractor configuration. And there's some others, this might be a prop, okay? A prop might be the part that goes on your favorite hat. So they're all props. So what kind would you say? An aircraft propeller, a boat propeller, or a novelty hat propeller, whatever you would call that, right? This right here, some of you have seen one, some of you haven't. So for those of you that have never seen one, this is a magneto. This is what has the magnets in it, which pass each other when the engine turns, which creates electrical current, which goes to the spark plugs, which generate spark at the right time, which mixes with the fuel air mixture inside the engine to create combustion, which causes an internal combustion engine to make power. That's electrical energy, all starts right there at the magneto. Some of you, this is magneto. Okay, so that's we got to be clear on aircraft magneto or DC Marvel Magneto, the comic book version, right? DC, not Marvel. I don't mean to confuse. Anyway, let's keep going. So mechanic, this is what a mechanic looks like to some of you when you think of a mechanic. To some of us, this is what a mechanic looks like. Okay, two different totally jobs, same idea. Is they're working on the mechanical aspect of that piece of transportation to make sure it works. They're both doing their job. Well, one of them's doing their job, but they both look the part for the engine they're working on. Here's a new one. So in Private Pilot Ground School this year, we started out with lift, and we talked about a new term. Okay, so aerodynamic lift is caused by two things. One, Bernoulli, thanks to as the air accelerates over the upper surface of the wing, it makes low pressure, which causes low pressure above. But then also Newton's third law says as you force air down below the wing, it's gonna the equal and opposite reaction is to raise the wing up. So weight is acting downward, lift is acting vertical. But to some of you, when you came into Private Pilot Ground School, this was lift to you. You're lifting weights and picking them up and putting them back down again. Okay, two totally different things. All right, and it can be confusing if we just say lift. And then another barrier to communication is being too abstract, overuse of abstractions. So let's say these are all examples of aircraft, or more vague, vehicle. Or even automobile, automatic, things like that. But these all three in their example here in the book are aircraft. Okay, this would be a lighter than air. This would be an airplane single engine land, and this would be a rotorcraft helicopter. So if you want to be more descript, be descript. Okay, do you see any questions on the components of a helicopter? Any questions on the components of a single engine land plane or of the Goodyear blimp? So some examples of all these. Okay, so when we say aircraft, that is an aircraft. So is the R-22 flying next to it. Just kidding. The R-22 wouldn't get anywhere near as high as your Boeing 777 would, but the ratio, just so you know, is just about the same. You can see one face in a window here. That's about the same size as one face in the window there. Let's put that in perspective also. There's the R-22, same picture from right there. And scale-wise, it's about that small compared to an H-53 helicopter. So if these are both aircraft, these are both helicopters, and they're quite a bit different from each other. And even more vague, they're both rotorcraft, which would then also include gyrocopters. Right? So gyroplanes, even more vague as it could be. That's what is this? You might say it's a turbofan. That'd be the best answer of all. But some of you might think it's an engine or motor, and that's not really what it is. It's actually a power plant. This happens to be a turbofan. That's the type of turbine engine that a gas turbine engine that it is, but it's a power plant because it doesn't just make thrust. It also makes electrical power, it makes hydraulic power, or it powers the systems that make hydraulic and electric power. This is a source of heat to warm up your cabin. This is a source of air pressure so you can not pass out from hypoxia at high altitudes. It's used to pressurize the cabin. So it does more besides just move the aircraft. It provides you power for everything else too. So power plant's the most accurate of those three, but really this would be like a Pratt and Whitney PT something turbofan engine would be the most explicit way. Here's some examples of some other motors. Okay, so you got your motorcycle V, you got your lawnmower, you've got your inline straight four like you'd have on a lot of older Jeeps. You got your V8 Chevy here. So these are all engines. So you don't just go to the aircraft store and say I need an engine. Okay, you need to say what kind of engine for what kind of aircraft, because maybe you'll get one of these and they won't fit. Another one is our external factors. So mainly, we talk about the physiological or the biological aspect. How well do you communicate? When you are being overwhelmed, you stop listening as well. When you get tired, you don't listen as well. When you get distracted, you don't listen as well. And so we need to know that's going to happen. So try to minimize your distractions and pay attention to what needs to be paid attention to, right? Environmental, as in airplanes are generally loud, okay? And we need a way to muffle the engine noise so we can operate without headaches and get less fatigued, but then so we can communicate together. So this was the bee's knees for years. This is the Bose A20 headset. As I'm recording this, they came out with a new Bose A30, which is even better. But I'm not going to go trading in my A20 just yet because I love it and it still works and I'm going to keep using it. And it wasn't cheap, so I'm going to get my money's worth from it. But then there's also psychological barriers to communication, like you tune somebody out because you don't want to listen to them, or because it's not something you want to hear, or because once again you're tired and your brain is trying to spend energy on not falling asleep, so it spends less energy paying attention. Some of which you might be suffering all right now. Okay, so the Bose active noise reduction is like the aviation version of a good hearing aid that might have some A&R on it too. So again, to tie it into non-aviation stuff, to overcome physiological factors of your hearing not working well enough, we compensate for that by giving you a hearing aid. In aviation, we give you a headset, and then the more expensive the headset, generally the better they work. And I will say one of the best things about this, of course, it got Bose noise canceling, which is top of the line, but the microphone is great too. So when you hear somebody on the radio and they don't sound very clear to you, it's either your headset sucks or their microphone sucks, and this has good both of them. So I guess if you're being cheap and you're saying it's okay, I'll just take Advil because I'm gonna have a headache because my headset doesn't work and it's kind of loud. Well, you're giving everybody else a headache too because your microphone doesn't work all that well either. So everybody else has to listen harder because of you. So don't spare the expense or don't spare the. Uh, it's a worthwhile purchase is what I'm getting at. So don't cut it short on that one. Interference. That's in as we're watching videos, if I'm on mute, you're not hearing me. So that's interference. Something is getting in the way of the receiver getting the symbol from the sender. And by now, everybody's been in a Zoom meeting or a Teams meeting, and people just start talking and their lips are moving, but you can't hear the words. So you got two options. Do you stop the whole meeting and you say, "Hey, you're on mute," or "Talk louder, I can't hear you," and then they always have to say, "Sorry, I was on mute," and then they say it all over again. So you know, anyway, that's plenty of interference there. Uh, Fun little quick story. If many flight schools still do this, when you solo an airplane for the first time, they'll cut your shirt tails off and then put some aircraft info on there. It's has some historical roots to it. So some of you know this. For the rest of you, a little history for you here. We used to fly an aircraft that didn't have headsets, and they were almost always tandem. So the student pilot sat in front of the instructor pilot, and we didn't have headsets. We didn't have an electrical system to power them, or a way to communicate back and forth in the air. The instructor would lean forward and scream directions into the student's ear, or we would have to make notes and talk about it after we land, and then take off and go try it again. Well, if we needed to give instructions or get the student's attention in flight, the instructor would reach forward and pull on their shirt tails, and that got their attention, so then they could listen to you or look at you. And the idea of cutting off the shirt tails is now no longer do you need the instructor to pull on your shirt tails to get your attention, because now you can fly on your own. Fun little story there. And then another huge one is, besides the lack of common experience, is the inability to communicate face to face. In aviation, this is particularly has a impact on us, because most of the time you cannot see the person you were talking to. I'm clearly talking about external communication. So a huge barrier to external communication is the inability to communicate face to face. So if you're the kind of person that talks with your hands, you got to find a way to not do that when you're talking on the radio. And I may or may not have done that while recording this video right now, because it is just too natural for us to do. So the problem is, when you can't see each other, you can't see the faces they make. You can't see if they are or are not paying attention, or if they comprehend what you're saying. So you have to go strictly off the words. And it makes it harder to confirm or to correct any communication that happened. It makes it easier to confuse call signs. You can confuse other aircraft with each other. You can confuse the call sign with the same aircraft. And honestly, it's possible to just forget about an aircraft altogether. Once you get 7 or 8 airplanes in the traffic pattern all at the same time, all with similar call signs, it's really confusing on who is who. And so one of your assignments for this week is a quick caveat, probably go check Canvas to be for sure, but one of your assignments is to watch a video about a mid-air collision that happened down at Brown Airport. It's a it used to be called San Diego Municipal Airport. That's why it's SDM, but it's actually Brown Municipal Airport now. But a mid-air collision that happened down there, and you'll have an assignment to do on that too. So. And then other cultural language differences. Okay, so waving with your left hand doesn't mean the same thing in some cultures as waving with the right, or a thumbs up might mean something else to some than others else. So there are differences too. So you need to keep that in mind when you're flying in different parts of the world or talking to pilots from different parts of the world. And I'm not going to get into this now because it's an assignment. I want you to go and hop over to the assignment. If we were in class, we'd watch this together and we would talk about it. But since we're not, you're going to go and watch it online, and you're going to do the online assignment instead. Okay, so some other barriers to communication are speech intelligibility. What I mean by this is, if you're trying to talk fast like air traffic control and say all the terms they are saying as fast as they are saying them, you're probably going to mess it up. And by trying to talk fast, you're going to mess it up, and then they're going to have to ask you for clarification, and you're going to have to say it again. And if you have to say it twice, it was not any faster than saying it one time slower. So within reason, you should talk at a good, understandable pace that specifically you can keep up with. You're not talking too fast or trying to say too much, because you can't keep up with the way they do it. Okay, they get paid to do it. Their traffic control gets paid to talk for a living. They're really good at it. So don't try to keep up with them. There's some other contextual differences. Let's start out with the nonverbal communication. That's actually called paralinguistic factors. It's how you say things. It's how you stress different words or the intonation you give when you say something. If you say something and it ends with something like this, then it sounds like a question. That's a nonverbal way of asking a question. If you talk something, if you're louder when you say something and you say it in a staccato method, then you're trying to get that one particular point across. Or sometimes the occasional pause, make sure that you're going to listen to the next thing I say, right? So it's all about how you say it, not just what you say. And try to eliminate any slang or jargon or any shortcuts or any trucker talk when you're talking on the radio. So the good example here is if you're cleared to climb and maintain flight level 310, you don't say climb to 31 or climb to 310 or up to 310. Your one and only response should be climb and maintain flight level 310 because that eliminates any other confusion, as in do a heading or a different altitude or something like that. So when ATC says specific things to you, they would like it read back in a specific way. For the most part, as long as you have like a conversational, communicative tone with them, the message will get across. But there are some things they need to hear from you. So try not to mess those up, or at least make note when you mess it up one time so you don't keep messing it up. Some things get in the way of that are homonyms. That's the same word, the same spelling, different meanings. I phoned this one in here because it's just a plural version of a word, but that's one aircraft and that's two aircraft. Okay, so it's the same word and it's spelled the same way, but it means two different things. So, like, they're not going to say, hey, do you see the aircraft off your nose? Ideally, they know who it is, and they're going to say, look for the flight of two F-18s at your 12 o'clock. That would eliminate a lot of questions and ambiguity. If you see them, there's a few different ways you can respond. Here's what I hear pilots say. I hear pilots say traffic in sight. That's probably the best way to say it. I hear contact. I hear tally ho. I hear I see them. Those work. Okay. I personally would say traffic in sight because that's what they want to hear. What if you don't see them? You can hear. You can usually most people would say looking or no joy. It beats some of the alternatives. Like, do not say traffic not in sight because that sounds a lot like traffic in sight, and those are kind of two totally different things. Negative contact, yeah, well, you said contact. Contact means see them. Negative means you don't. So it's the negative opposite of the affirmative. It's keep it clear if you just said traffic in sight or no joy or looking. If you do or don't see them. This is, of course, a pet peeve of mine and every other teacher's. Not even this one. It's your. Yours the big one that really gets us in trouble. So there is a homophone. It's three different, same sound, but it's three different words. They all sound the same. There, and there. But it's actually there, and there. Okay, so they mean three different things, and they're spelled differently. It's not one word that does all those things, folks. There's three different words. Of course, some other ones, your and yours, the big one. And then two is also number two, and then two someplace, right? They're all different things too. And then the your and the your, I mean, if you're going to be like, I don't know, a professional or a tattoo artist, you should know how to spell the correct your before you tattoo it on somebody's back. I just want to make sure that you know that you can't go back on this decision and this grammatical error here. Okay, folks? That should have been you are mine, and that's not how you spell you are. That's you are, not you are mine. Okay? All right. And, like, for instance, if they tell me to turn right heading 150, I should respond back with turn right heading 150. We kind of say five in over the aviation radio is fife to make it more clear. Not right 215 or right 215 because it kind of sounds like that or that depending on which word they think you're using. Okay, so the correct answer, turn right heading 150. Usually don't say two because it sounds like a number two, right? Or switching back and forth between proper and non-proper English through slang or trucker talk to aviation talk or one language to another. Try not to do that. Try to stick with one and go with it. I blame a lot of these problems on autocorrect. It has become our worst enema, um, because we don't write anymore or look up words anymore, and so we just let the word processing software do it for us, and we're giving it too much responsibility. I'd like you to take some of that back under your wing. Make sure you use the right words at the right time. So we need to effectively communicate, and part of that is if to listen effectively. By listening, I don't mean hearing; those are two different things. Okay, hearing is the sound is reaching your eardrums, and it makes a reaction there. That's hearing something. Listening is hearing with comprehension, is actually paying attention or understanding what is being said. A few keys on how to do that, or you need to listen for the big picture, not just try to memorize facts. And you're trying to pick up the reason it's being said. Why are you listening to that? And if you figure out why, then it's easier to take notes, it's easier to pay attention and to listen to it. Speaking of, if you're taking notes, you don't have to write down every word we say. It should be bullet points, it should be to the point. You just want to show us the highlights of what you're trying to say. And don't listen just to argue. Okay, don't stop listening just waiting for your turn to speak. That's not the best way to do it effectively. We countermeasure some of these by some readbacks. For instance, reading back the clearance. I get an instrument clearance, I read it back to make sure I got it right, and then they either read me back the corrections or they read me back to tell me that it was correct. So they transmit you the clearance, I write it down, I read it back, they either fix it or they acknowledge that it was correct, and then we're good. Then we're finally done. Other ways are using the right words and standard phraseology so that all the same words mean the same thing to all of us, and to brief each other in a cross check. Let's start out with a readback. Okay, we do it because it makes sure that it was done correctly. On the graph, we just saw the same graph. So here's an example readback. It's a pilot out of Montgomery Airport getting a craft, an instrument clearance to a local airport. And they do a lot of back and forth on this call. First, both the pilot and the ATC controller mess up their own names when they call each other, so it must be early in the morning before coffee. But then it kind of only gets worse from there. The pilot keeps omitting a very important word. I don't want to give it away. I want you, if you are a flying pilot, if you are an instrument student or instrument pilot for certain, you should watch this. And then anybody else, if you want to figure out what word the pilot was neglecting that the ATC controller was telling him to say, then it becomes very obvious at the end of the video. You should definitely go watch it and see. I'm going to link to it also in the comments down below and on the Canvas page for you too, to make it easier on you. What cross-checking is two people do the same thing, but they do it on their own, and then they double-check each other's work. To put it simple, this happens, let's say, when you go on a commercial flight, the operations agent would do the weight and balance, as in how much fuel is on the airplane, how many people and how many bags are getting put onto it, and then they do all the calculations, and the pilot double-checks it. The captain will double-check it and sign for the airplane. You see this every time you pull into a gate in a commercial aircraft. When you pull into the gate and you'll hear disarm or doors disarmed and cross-checked. So you pull into the gate and the flight attendant will disarm the door. So when they pop open the door, the slide doesn't pop out. That's what they're talking about. But then just to make sure they didn't do it wrong, they have to let somebody else double check their work, and then they double check the other person's work. So in aviation, you shouldn't get upset about somebody double checking your work. It's there. It does a good purpose. It's there for a good reason. And then the other video you just watched was the instrument clearance, how they had to keep going back and forth and had to fix that one. And there's many others, obviously. We use standard calls and phraseology, so it's unambiguous. It's very precise. It's very peculiar. It's hard to mess it up and confuse them. In the video, It was heading. I'm giving you the answer right now. He didn't say the word heading. Literally, like he got everything almost right, and then he didn't say the word heading, and the controller needed it. He needed to make sure that he was turning left heading 270, not turning left 270, because left TO 070 degrees would be east as opposed to heading 270, which would be west. Those are kind of two different directions, so that's why the controller had to hear that word on there. Line up and await means something specific. It means get on the runway and wait for takeoff clearance. And that's a specific clearance they make you. And when they tell you that, you have to read that back to them too. And that's also the same staccato and clearance when they say runway whatever, cleared to whatever, um, as opposed to yeah, go ahead or you're cleared to land or something like that. No, they say runway 27 cleared to land. Even if there's only one runway, they have to say runway 27 cleared to land or cleared to take off or whatever else. And then every time you change the flight controls with your instructor, you're going to do this positive three-way exchange of flight controls. Here's your example down here. I would, as a CFI, if I just demoed a maneuver and I want you to take the controls and for you to try it, I would say, you have the flight controls. You would say, I have the flight controls. And I would say, you have the flight controls. And then I'd go one step further and I would pop out my jazz hands and I would show you physically with my hands in front of you that I'm not touching the flight controls. So there's no doubt in anybody's mind who's doing the flying now. Now, once you become more professional, you standard calls become even more important. Here's a standard operating procedure at a regional airline for takeoff um, steps and calls that each pilot has to make, and literally word for word the call that they make. They're in quotes in capital letters. This pilot monitoring should announce 80 knots, thrust normal, and the pilot flying will confirm that the airspeed is 80 knots because they're cross-checking the other pilot, and then they announce checks. Not any other way of doing that. Not at any other speed. Not at any other words that it would be said or how it was said. They want it to be said just like this. And if you don't like that, go work at a different airline because that's this airline's SOP. Briefing is another good way of making sure everybody's on the same page. It establishes situational awareness for all people involved. And it lets everybody know who's doing what and when they're going to do it and how to do it. For instance, here's a video of a pre-departure brief between a captain and a first officer. It's only a few minutes long. You should hop on over and go watch it. See the links down below for it. You see the first officer with 3 stripes and the captain with 4 stripes are discussing where they are, where the head spots are, how to get to the runway, what runway they're going to use, if there's an emergency when they take off, who does the flying, who does the radio talk, where they're going to divert to, and what they're going to do about it, and who's going to use the checklist, who's going to do the radio, and this is a chance for make sure everybody's on the same page before they push back and take off. And it got some feedback from the first officer. So he's the ranking pilot in the flight deck. It's technically his aircraft right now, but he's still soliciting good input from the first officer to make sure that he didn't do anything wrong as well. And I'll link that for you also. Personally, you'll get really good at doing a pre-takeoff briefing. Like you're in your 172 and you just did your run up and you're just about to call tower for a takeoff clearance, but you want to make sure you do your pre-takeoff briefing first. It would be something like, okay, we're doing a straight out departure. It'll be a normal takeoff, full throttle. I need to rotate at 55. I need to climb at 74. We're going to start our right crosswind turn at 1100 for a right downwind departure, departing off towards the east. Then I go on to the emergency part of it, and I'll say, like, if something doesn't look right, sound right, feel right, smell right, or even taste right on the takeoff roll, we're going to pull the throttle back to idle and get on the brakes and get it stopped on the runway if we can. If we have an engine failure occur above 500 feet, I'll point at the gauge, or below 500 feet, I'll point at the gauge. I'll say we're pitched for best glide of 65 knots. We'll land somewhere in the windscreen in front of us, and we'll do what we can with the time that we have available. If we have an engine failure occur above 1,000 feet, and I point at the gauge, I'll say we'll pitch for best glide of 65 knots. We'll attempt to restart the engine while we return to the airport for landing or a better landing site, and we're going to get on the radio and the transponder and make sure people know we have an emergency. Any questions? and that lets my passenger or pilot, I guess my pilot, co-pilot, see if they have any questions, or that's an opportunity for my passenger to get out of the airplane because I just talked about all the things that go wrong in a takeoff. So, a briefing, get everybody on the same page. So that sums up our communication part of this video. We're not quite done yet. We talked about things that go wrong with aviation communication. Mainly, we have a lack of common experience, and things that go wrong with our external communications because we can't see the person that we're talking to. We talked about homophones, homonyms, and really quick synonyms. Like we try not to use them too much. We have standard phraseology that we want to use as a countermeasure to bad communication. So try not to get too creative on your vocabulary when you're talking on the radio. Try to keep it simple and to the point. And the key in all these is consistent use is vital. That's what you need to do. You need to consistently use countermeasures. Not just whenever you feel like it, not just sometimes, because the time you don't is the time you wish you would have. So consistently use all those countermeasures. Let's move on to the next kind of part of our topic. Since we kept talking about 99% of the communication you do in the air traffic controller is over the radio and verbally, let's talk about air traffic control and see what they do. Here's a really nice video. Check it out up here and or in the links below or in Canvas. It talks about a typical day in the life of air traffic over the U.S., and this was like 17 years ago or something, when we have a lot more airplanes flying around now than we did then. So at 8 p.m., you see things start to, everybody in the East Coast starts to go to sleep. Everybody in the West Coast is still awake. You see all the transcontinental flights are departing. Everybody's headed off towards Europe now that the sun sets. They can be there midday the next day. Middle of the night, we're down to like 600 airplanes that are in the sky. And then as the sun starts to come up, you see all FedEx starts to depart the Memphis hub. And then you see all the East Coast airlines start flying people around too. We're still asleep here on the West Coast. Couple flights coming and going, but for the most part, we're all still sleeping. And as the sunrise comes towards the west, more and more planes start to depart. You see the hubs here, like at Denver or Dallas or San Diego or Los Angeles or San Francisco, where all the airplanes are coming and going, high density areas where people go to get on different airplanes, right? And you see the restricted areas here and here where basically no aircraft are flying through because it's restricted military airspace, for instance. And what happens when weather interferes with all these, 5,000 airplanes at a time that are flying around? A little bit of weather can cause a lot of delays. This one is the line of thunderstorms that came through Teterboro area. You see all the aircraft in holding patterns, these racetracks that are out here. See airplanes getting diverted to go way over the ocean instead of direct in from where the west where they were coming from. So a little bit of weather has a lot of delays and a huge impact. And in this example, it was like 4 hours worth of delays because of the weather. And you see the total counter. There's over 5,000 airplanes in the air at any one time pretty much during this whole video. Up to 5,500. And then we start dropping off as the day starts to get on and less flights start to go during the night and the afternoon instead. Alright, so go check that out. It's pretty crazy. Here's another video. I'll link that one down below and in the Canvas as well. It's basically how they came out with the airspace that we have here in San Diego right now. The Metroplex is the specifically for commercial aircraft that are coming and going with paid passengers on them. Jet aircraft mostly out of San Diego International, Carlsbad, that's in Palomar. We've got Long Beach, Orange County, Ontario, LAX, of course, not to count them out. Riverside, the crazy amount of air traffic that's happening around here. And this is how they coordinated the routes they used to depart or the routes they used to arrive into different airports and different arrival and departure procedures and how to get on the approach. And it's pretty crazy how it's all laid out. So if you're in like the next step of our aviation degree, go check that one out. And that's how the airspace got designated around here. ATC, okay, so there's kind of two main jobs. The radar controller, their job is to ensure separation on a radar screen. A tower controller, their job is to ensure is to make sequencing and provide efficient traffic flow to and from the runway. So if you're talking to a radar controller, they're supposed to keep you from running into anybody else. But if you're not in the clouds and you don't have an instrument clearance, that's still your job, is to make sure you don't hit other airplanes. They're just there to help you do it. Now in the traffic pattern, there's a lot of airplanes. They're really close by. It's up to you not to hit another airplane. It's not really their job. They do their best to sequence you and let you know about each other, but you still need to look out the window and not text and drive and not hit the airplane that's in the traffic pattern with you. So still keep your eyes peeled when you're looking outside. Aviation is a 24-hour job. Somebody's got to do it. And as we've discussed earlier in this class, if you're not working during the day, you have a tendency to get tired and fatigued when you're working at night because your body is not used to it. Even if you've been on night shift your whole life, it's still causing problems with you. Problem when you get fatigued, you don't pay attention as well, you can't concentrate as much, and it impairs your coordination, like how you do things and your timing when you do things, and it decreases your ability to communicate. So that's why we talk about it here, because we're talking about communication. So if a controller gets tired, they don't communicate well enough, they're not being as good of a controller anymore. So that's what we're trying to avoid. The two types of fatigue, physical and mental, the two types of those fatigues are acute and chronic. We've already discussed all these in physiological factors and aeromedical factors. Acute fatigue, you can sleep it off. Chronic, you need to go see a doctor because something else is going on. Now, here's just a couple of mistakes that ATC has made. There's usually more to the story. This is a picture of the crash of a U.S. Air and I think a SkyWest flight in Los Angeles in 1991. Basically, if I tell you the footnotes, you're going to think it was all the controller's fault. She put an airplane on the runway, forgot about them, and landed another airplane on top of them. Okay, it does sound pretty bad, actually, when you say it that way. But there was a lot more to it, such as it was nighttime. They had broken equipment in the tower, so she couldn't see who was on the surface, taxiways, or runways. There was a missing flight strip for the departing flight, so there wasn't a piece of paper in front of her saying it was there. And there was a glare off a parking light that put a reflection on the window, like right where she would have needed to see the airplane that was on the runway. They were landing and departing 4 runways at the same time in Los Angeles when this happened. And then to make it all worse, an airplane that was supposed to be talking to that tower that she needed to clear across the runway so she could take off an airplane was on the wrong frequency. He landed and switched to the wrong frequency. So she had an airplane on the runway who she couldn't clear to take off because there's another airplane she needed to get off across the runway first, and they were on the wrong frequency. Meanwhile, US Air here called in a couple times on the landing for straight in, and then finally she got a hold of the airplane that was on the wrong frequency, cleared them across the runway, cleared this airplane to land, and then lo and behold, there's a big fireball. So there's a lot more to the story than she just forgot. Okay, so all those added distractions added up quickly. So I'll link to all these videos and everything down below and in Canvas again. The next one is a runway incursion, but not a fatality. It was not a collision on the runway. So a runway incursion is the FAA term for you were on a runway you weren't supposed to be, or you were in somebody else's way on the runway, or something bad could have happened. So a runway incursion ends in either a collision, such as this one, or a near miss like this one. In short, what happened here was the controller took this airplane to take off, cleared this airplane to take off on an intersecting runway, while the giant 747 here was landing and rolling out on the intersecting runway. There's more to it than that. Okay, so this airplane got on the runway but wasn't ready to take off yet. So the controller's plan of taking this plane off and then landing this one got a little bit upset because this airplane was on the runway and then wasn't ready to take off yet. And then the controller wasn't able to kind of switch gears and make alternate plans to this one. In the end, the controller should have said, okay, well, I'm glad you're ready now, but now I can't clear you to take off, so now you get to sit there and wait a little bit longer. Would have been the right thing to do. Let the 747 go through the intersection, clear off the 737, no harm, no foul, everybody's on their way. But what happened was the airplane got on the runway, they weren't ready to go yet. A couple of minutes later, they said, hey, we're ready to go. Controller cleared them to take off, clearly forgot this one wasn't through the intersection yet. They saw each other, they avoided from hitting each other, but it could have been a whole lot worse. Here's a nice video about air traffic control. This one happened here in Southern California. This was an accident that occurred and two aircraft that are en route to go land at Palomar Airport, I believe. It was 304 Papa Alpha and 434 Papa Alpha. There are two different Seminole aircraft from the same airport going to the same airport for the same approach at the same airport at night in trail, like one's just a few dozen miles behind the other one. And really simple here, the controller, let's say for example, cleared this airplane to descend, but instead used this airplane's call sign. So this airplane answered back and descended instead of this airplane. And unfortunately, there was a mountain range in between here that this airplane had not climbed on, had crossed yet. So the point here is ATC, they're great. They got a lot of tools at their disposal, but don't just blindly do what they tell you to. You are responsible for your own navigation, and people make mistakes. So we need to find a way to keep that mistake from becoming a bigger deal. But it isn't always ATC's fault. Here's a list of videos of times that it was not air traffic control's fault. On this one here, well, not all are ATC's fault. On this example here, link down below in Canvas. You should check it out, especially if you're a pilot. If you're a student pilot or above, you need to watch each one of these because you don't want to be on the next Air Safety Institute video. This United Airlines flight landed, taxied off on November. They were supposed to cross runway 23 right at November to Tango, taxi into the terminal area. It was really foggy. Tower couldn't see them. They took this left turn instead of this left turn and ended up almost crossing back across the runway they just landed onto. You're like, oh, can't they see the runway signs or the taxiway signs? Probably, but it's super foggy, so they can't see them all that well. They definitely couldn't see around the airport or where they're going. Another example of an aircraft at night, and it's hard to see where you're going. Well, anyway, this plane takes off and darn near hits them, and then the controller attempts to keep taking airplanes off because she doesn't really understand where this airplane is. And they start panicking on the radio and let them know, and I'll let you watch the video and see the happy ending and how it resulted in this video. Here's a good example of it's not always ATC's fault because in this example, there wasn't even an air traffic controller there. This doesn't have a control tower at the airport. Just a small chain of events starting with a bad communication breakdown resulted in 14 fatalities. We will listen to this one.
It's a few minutes after sunset on a chilly November afternoon in the Midwest, and a Beech 1900 regional airliner has just reported 10 miles north of the non-towered Quincy, Illinois airport, inbound for runway 13. On the ground, a Beech King Air is preparing to depart on runway 4, and behind it, a new private pilot in a Piper Cherokee is waiting his turn for the same runway.
Quincy traffic, King Air 1127 Delta, holding short of runway 4. Taking the runway for departure and heading southeast Quincy.
The transmission catches the attention of the airline crew, who are planning to land on the intersecting runway 13. 25 seconds later, they announce their position for a second time.
Quincy area traffic, Lakes Air 251 is a Beech airliner currently just about to turn a 6-mile final for runway 13. More like a 5-mile final for runway 13 at Quincy.
In the meantime, the King Air has taxied onto runway 4 and stopped, apparently to complete some last-minute pre-takeoff items. For reasons that are unclear, the two pilots of the King Air are paying little, if any, attention to the CTAF. Another 45 seconds pass, and the 1900 is now on short final for runway 13. From the air, its crew can see the King Air still holding in position on the intersecting runway.
And Quincy traffic, Lakes Air 251's on a short final for runway 13. The aircraft going to hold in position on runway 4, or are you guys going to take off?
The response comes not from the King Air, whose crew is apparently still preoccupied, but from the inexperienced pilot of the Cherokee, waiting at the threshold of runway 4.
7646 Juliet, holding for departure on runway 4.
Mistakenly believing this transmission is from the pilot of the King Air, the crew of the 1900 thanks him for his courtesy.
Okay, well, we'll get through your intersection in just a second, sir. We appreciate that.
But the King Air is no longer holding in position. It's starting its takeoff roll. and the relative positions of the converging aircraft are such that the airline crew doesn't see the King Air until it's too late.
Max reverse. Oh.
The relatively low-speed collision leaves both aircraft largely intact. But fire, smoke, and a jammed exit door in the 1900 prevent any of the occupants from escaping. The tragedy holds clear lessons for pilots. At non-towered airports, moving into position and holding on a runway is a bad idea. And inappropriate or ill-timed communication, even if well-intentioned, can lead to serious misunderstandings. The accident also shows the importance of listening to the CTAF and visually clearing the departure path prior to takeoff, especially if a runway intersection lies ahead.
All right, so maybe if they're not talking to you, you shouldn't say anything. That's the inability to see face to face was very apparent there because the pilot didn't know of the landing Beech aircraft, didn't know which airplane she was talking to, and she was clearly not talking to the pilot who was on the runway taking off. So that pilot should have kept his mouth shut. It's too bad. So again, it's not all ATC's fault. Not only that, they save a lot of lives. Okay, so a few things to remember: that when you're flying an airplane, you have an emergency. You can't just call ATC for help right away because they can't reach through the radio and fly the airplane for you. So you still have to aviate, navigate, communicate. You still fly the airplane. You still put it where you need to. You still manage the aircraft, and then call. And every year they come out with what they call Archie League Awards. These are awards from FAA, well, from NA, the Air Traffic Controllers Association, and they're giving awards to controllers who just did their job just like they do every day, but one day was just a little bit more important than others. Usually it's when pilots' lives are saved is when the Archie Leagues would come in. Again, they do a great job all the time, but when there's a situation and when the controller gets the pilot out of trouble is when the Archie League Awards come in. There's quite a few of them. I'm not going to talk about all of them. Here's just a couple examples. Again, I'll link everything down below for you to check out. Student pilot who flew into some clouds around Pueblo area, and then somebody else who had an engine failure and had to put it down on a highway somewhere. Really quick, how many people you talk to? Just did a quick flight here from KMYF, Montgomery Airport, up to Northern California to SMF Airport. You talk to ATIS, you talk to clearance delivery to get your clearance, you talk to ground control, they get you to the runway, you talk to tower control, they get you in the air. A terminal radar approach control facility. Down here we call them SoCal. You talk to departure control, they would clear you through a couple sectors of airspace with a couple different frequencies, and they'd switch you over to LA Center, and that's the En route Traffic Control Center, the ARTCC. And then as you start descending towards your destination, you're up in NorCal. You're talking to a terminal radar approach controller again, TRACON or NorCal for short. You'd be talking to an approach controller. You'd go from one sector to the other, and you'd be changing frequencies as you do. And then when you get close enough to the tower, you talk to tower. They clear you to land. You talk to ground, then clear you to taxi. And some busy airports, you might even have a ramp control where they clear you in and out of the ramp, so you know which gate to go to and stuff like that. So on just this flight, your pilots are probably talking to 15 or 20 people, and it's all done with voice over the radio. So much radio traffic is involved in every flight. It is crazy. And again, I'll link a couple of these down below. And I mentioned at the very beginning of this, I talked about the ASRS, but we never really got to talking about it. So the ASRS is the Aviation Safety Reporting System. It's a way of gathering information so pilots can self-report safety concerns, and their information is not pushed through. So when you make an ASRS report, we also call it a NASA report because it's the National Aeronautics and Space Administration that handles the ASRS reports. So if you file a report with your information and stuff on there, NASA gets it, and then they strip off your info and they let the FAA know what happened. That way the FAA knows that there's safety concerns or incidents that are happening there, but they don't tattle on you and say who did it. Your incentive for doing this is you get a little bit of an immunity So you get a get out of jail free card for filing a NASA report. So let's say if you go and violate Bravo airspace without a clearance because you got distracted and crossed the line and didn't get to call first or something like that, you can file a NASA report. You get an envelope and a letter in the mail, and you get a code and an email all saying that you did it. In that NASA report includes what happened and where it happened and what you recommend to do to keep it from happening again and things like that. And then let's say a couple months later, the FAA comes knocking on your door and saying, "Hey, you were flying this airplane this day and you violated this airspace. You're in trouble." And you say, "You know what? I absolutely did. I filed an ASRS report with NASA, and here's my receipt for doing so." And there's a good chance your conversation ends there, and they say, "Oh, well, you know what? Thanks for doing your part to make aviation safer. Have a nice day." They may say, "Okay, well, you're not in trouble anymore because you have that get out of jail free card, but tell me what happened." They might want to know more info. Um, but it can help. Now it's, if you do something egregiously wrong, it's not going to get you out of jail free. Okay, so it's like you made a mistake. It'll limited immunity. So, but it's there for you. Now that's for all general public, for everybody. If you work for an airline, they have what's called an ASAP program, or Aviation Safety Action Program, which is kind of like an ASRS system, but it's within the airline. So that's a chance for you to tell the safety officer or the president of the company or something else uh, a safety concern and let them handle it at a lower level. And again, they are also unanimous. They won't know who it is. They can't come and crack down on you for putting it in there. But each company has kind of their own way of doing it. So make sure you know how your company's ASAP program works before you go and start complaining about your boss on it. That pretty much sums up this video then about ATC communication, about ATC, how to effectively communicate and how to effectively listen, and the effects that fatigue has on you and ATC, things they do wrong and things they do great. ATC, if you ask them, they say it's the best job in the world, and they're probably not too far off. The pay is great, the places are great, the people are great. Well, most of the people are great, but it's an amazing job. It's vital to the industry, and if you want to become an air traffic controller, you can. You just have to hire for it. Like, you don't even need training, and the bar set pretty low on them screening you, and then once you get in, they do all your training. It's a federal job, so there's great pay, or there's good pay, and there's great benefits. Let's put it that way. And there's a lot of places you can go, but it's a federal job, so they're going to put you where they need you. So no big deal. You just spend a few years wherever they place you, no matter how miserable it might be, and then you put in for a transfer to somewhere you really want to go to. The busier the control towers, the more stress there is, but the more money you make. But hey, more money, more problems. If you're watching this video before May 5th, 2023, you should hurry up and apply. If you're watching this video after May 8th, 2023, you need to watch for the next window to open. You just put that in your internet and they will tell you when the hiring is, and they send you the link to USA Jobs and where to go apply for it. And for any other assignments, go ahead and refer to your syllabus. See what else there might be due. I think that's it. Thanks for watching, folks.